Okay, today we are going to study the refraction of light. Okay, so what is refraction? This is a suppose this is a suppose this is a slab of a mirror, slab of a glass. যেটা কাঁচের একটা স্ল্যাব, ঠিক আছে? তো consider a light travel, consider a light travel and incident on the surface. Okay, and this is this and after refraction it changes its direction. Okay, so this phenomena is called refraction. So if incident ray is 100%, so sum of light gets reflected and the rest of the light get refracted. Okay, so this phenomena is called the refraction and this phenomena is called the reflection that which we study before. Okay, now the definition of refraction: the phenomena of change of its path of light at the boundary of separation of two medium as it goes from one media to another medium called diffraction. So you can see, so when a ray light goes from a rarer medium to denser medium, it bends towards the normal, and in this case I greater than r. So you can see this is the separation x dash, this is the separation. Okay, and this is the normal n dash, this is the normal, and the ray AO coming and incident on the surface of the separation of the two medium, and after refraction it passes through this direction, not this direction. So the dotted line shows the actual path if the denser medium is not absent, in the case when the denser medium is absent. But if the denser medium is present, if the denser medium is in the position of and you can see and this is the angle of incidence I, and this is the angle of refraction r. So the deviation is I minus r. This is the deviation. Okay, this is the delta deviation, you can see from the figure. This is the deviation delta. Okay, the actual path and the refracted path, the angle between actual path and the refracted path, refracted light. Okay, and when a light goes from a denser medium to a rarer medium, it bends away from the normal. It bends away, you can see it bends, this is the normal, and away from the normal. And the previous picture you see this come closer to the, this refracted ray come closer to the normal, and in this figure you can see the refracted ray bends away from the normal, and in this case this is the deviation r minus r. Okay, so this is denser medium, the upper medium is denser medium and the lower medium is rare and medium, and in this case the upper medium is rare and medium, and lower and this medium is dense and medium. Okay, so when light goes from rare and medium to dense and medium, so this happens, and when light goes from dense and medium to rare and medium, this phenomena would happen. Okay, now this is the law of refraction. The incident ray and the refracted ray and the normal to the interface of the two media at the point of incidence all lie in the same plane. Okay, so you can see this is the normal, this is the incidence ray, this is the refracted ray, all lie in a plane. And the second rule is very important. For two particular media and for a light of a given wavelength, you have to mention these 2 points. Okay, for two particular media and a given wavelength, the ratio of sine of the angle of incidence to the sine to the angle of refraction is constant. So what is sine and what is, so you have to know from your math teacher what is sine and what is cosine function. Okay, this is trigonometric function. So sine, so this constant is known as the diffractive index of second media with the respect to the first media. Okay, so now we can write in this in this manner: sine I, this is sine sin, sine, this is I, the sine of this angle, and sine of this angle, sine R. These two ratio always remain constant. Okay, and this constant is termed as refractive index. This is denoted as mu. This is denoted as mu. Okay, this is denoted as mu. Okay, Greek letter. Okay, and this mu symbolize, the mu is symbolized as 1 mu 2. This means the this is mu is refractive index, and 1 and 2, the symbol represent the refractive index of second media with respect to the first media. So this is the refractive index of second media with respect to first media. Okay, with the respect with respect to first media. Okay, so this notation should memorize, and this is known as Snell's law. Okay, so when you are asked what is Snell's law, you have to write this second law. Okay, when you have to, when you are asked what is refractive index, the answer is same. We have to write this portion. Okay, okay. The next topic, the absolute the absolute refractive index. Okay, when light travels from vacuum or air to any transparent media, then the refractive index of medium with respect to a vacuum is called the refractive index. Okay, ভ্যাকুয়ামের রেসপেক্টে কোনো মিডিয়ামের রিফ্র্যাক্টিভ ইন্ডেক্সকে বলা হয় অ্যাবসলিউট রিফ্র্যাক্টিভ ইন্ডেক্স. So mu, this is mu, refractive index is defined as speed of light in a vacuum by speed of light in a medium. This speed of light is denoted as c, and the speed of light in medium is denoted as b. Okay, this is a very important relation. Okay, and next, the refractive index. What is refractive index? When light travels from medium 1 to a medium 2, then refractive index of medium 2 with respect to medium 1 is called relative refractive index. This is relative refractive index. Okay, so it can be written as 1 mu 2. So 1 mu 2 is mu 2 by mu 1. Okay, and refractive index has no unit and no dimension, so it is dimensionless quantity. And next, the dependence of refractive index. The value of refractive index depends on the nature of two media, okay, and the temperature of media and wavelength of the light. Okay, there are three factors which are the depends on the nature of the media and temperature and the wavelength of the light, but it does not depend on the value of I for the pairs of media. Okay, next, here is a question: what is the relation between refractive index mu and lambda? Lambda is the wavelength of light, so this is the relation. Okay, so this is the relation according to Cauchy formula. Mu is equal to a plus b by lambda. So you can see from the relation that mu proportional to 1 by lambda square, that is mu is inversely proportional to the square of lambda. Okay, so if mu increases, so lambda decreases and vice versa. Okay, so you see, as mu increases, as lambda increases, mu decreases. Okay, now a note: a medium in which the speed of light is more is known as optically rare medium, and the medium in which the speed of the light is less is known as optically denser medium. মানে কি বলছে, যে মিডিয়ামে লাইটের বেগ বেশি সেটাকে বলা হচ্ছে ডেন্সার মিডিয়াম, known as optically rare medium, and যে মিডিয়ামে লাইটের বেগটা হচ্ছে বেশি সেটাকে বলা হচ্ছে রেয়ার মিডিয়াম, অ্যান্ড যে মিডিয়ামে লাইটের স্পিডটা কমে যাচ্ছে সেই মিডিয়ামকে বলা হবে অপটিক্যালি ডেন্সার মিডিয়াম। ঠিক আছে, আমরা যখন বলছি অপটিক্যালি ডেন্সার মিডিয়াম, রেয়ার মিডিয়াম, তার মানে কিন্তু এই না যে তার ডেন্সিটি বেশি বা ডেন্সিটি কম, ডেন্সিটির সাথে এর কোনো রিলেশন নাই। দেয়ার ইজ নো রিলেশন বিটুইন ডেন্সিটি অ্যান্ড ডেন্সার মিডিয়াম। ওকে, okay, now for two media, the Snell's law tells that mu1 sin I is equal to mu2 sin I. Okay, so in this figure we can write this is the interface, this is the interface of two media. So light fall and get refracted. Okay, this in this medium the refractive index is mu1, and in this medium the refractive index is mu2. Okay, mu2. Okay, now what do we write? So for two media, the mu1 into sine, this is the normal, this sine I, angle is sine I, okay, is equal to mu2 into sine r. This angle is r. Okay, this angle is r, so sine r. Okay, so this is the relation you have to remember. Okay, the next, this is a very famous relation. For Snell's law, it can be written as 1 mu 2. This means refractive index of medium 2 with respect to 1 can be written as sin I by sin r is equal to v1 by v2 is equal to lambda 1 by lambda 2 is equal to mu 2 by mu 1. Remember, 1 stands for first medium and 2 stands for second medium. Okay, here v is the speed of the light in medium 1 and v2 is the medium 2. Similarly, lambda 2 and lambda 1 are the corresponding wavelength. Okay, the next topic is the condition for no refraction. So this is the condition when the rays are 90 degree. When the incident ray fall on the medium at an angle 90 degree. So in this case, there is no refraction. Okay, and when there are two conditions, no refraction occurs when the incident light incidents normally on the boundary of media. So in this case, when I is equal to 90 degree, and the second condition is no refraction occur at the boundary that separates two media equal of refractive index. So if this is the surface between two media, so if the refractive index here is mu, the medium 1 and medium 2 is the same refractive index. So if refractive index of both medium is same, then no refraction occurs at all. Okay, so this is the condition. This is the first figure and this is the second figure. Okay, you can see this is the medium 1, medium 2, and both have the same refractive index. Okay, the next topic, you have to remember the relation lambda red greater than lambda violet. So mu red less than mu violet. তো কি বলছে যে রেড যে কালারের লাইট তার ল্যাম্বাটা বেশি হবে কার থেকে, ভায়োলেট লাইটের থেকে। এটা কি ইমপ্লাই করে, রেড লাইটের আবার মিউটা কম হবে, মিউ মানে রিফ্র্যাক্টিভ ইন্ডেক্স। আর ভায়োলেট কালারের যে রিফ্র্যাক্টিভ ইন্ডেক্স, ঠিক আছে, ভায়োলেট কালারের জন্য কোনো মিডিয়ামের রিফ্র্যাক্টিভ ইন্ডেক্স সেটা কি হবে, সেটা হচ্ছে বেশি হবে রেডের থেকে। ঠিক আছে, একটা কথা তোমাদের মনে রাখা দরকার, মিউ এই যে আমরা রিফ্র্যাক্টিভ ইন্ডেক্স বলছি, রিফ্র্যাক্টিভ ইন্ডেক্স কিন্তু কোনো মিডিয়ামের হয়। ঠিক আছে, রিফ্র্যাক্টিভ ইন্ডেক্স অফ গ্লাস, রিফ্র্যাক্টিভ ইন্ডেক্স অফ ওয়াটার, ঠিক আছে, কিন্তু রিফ্র্যাক্টিভ ইন্ডেক্স কিন্তু লাইটের হয় না। ঠিক আছে, নোট, very important note, whenever light goes from one medium to another, the frequency of light does not change. So frequency of light does not change, but the velocity of the light and wavelength of the light change. So frequency nu does not change at all. So you have to remember for short question.